Welcome to the second lecture in the course data mining. In this lecture, we will cover techniques for preprocessing the data. As I had discussed before, the data mining process consists of the following steps. So, you have your data in a database on which you do a integration among all the sources of the data. So, it is not just one database, but multiple databases, and you integrate the data, you clean the data, and this integrated and clean data is in a form where it is stored in something called a data warehouse, the details of which we will discuss in our next lecture. And then you select the relevant data by a process of selection, and I have collapsed the steps in between. So, relevant data means not only selecting the records which are relevant, but also the attributes, the characteristics of the data, various such aspects of the data, and you form the relevant data. So, this step of getting from the data warehouse where you have a integrated data to the step where you have a relevant data only is known as the data preprocessing step. And finally, what we do is that on this preprocessed data, we fit a mathematical model which describes the patterns present in the data, either association rules or classification rules. We have a mathematical description of this clean data, and then we evaluate the patterns, evaluate the models, and those evaluated and visualized model which is usable by an human into some actionable form is what we call a knowledge. So, before going into the details of the mathematical modeling part, in this lecture we will cover the preprocessing tasks that you have to perform before you start the data mining. So, before describing what are the preprocessing steps, let me just clarify once more what exactly is we call as data. What is the actual form of data, the computer representation of data that we will be processing. So, there are various forms of the data. One of the most popular form which we will use in most of the data mining processes is in the form of a table. So, this table you see on the right is the basically your data. So, as you can see, the table is a two dimensional structure. It has some columns and it has some rows. Just like a relational database system, each of these columns represent some measurements or some observations. For example, suppose I want a data mining system to evaluate whether a person who has applied for a bank loan is a genuine person or a fraud person, a cheat person. So, maybe this is our data mining task that some bank has asked you to do it, and each of the rows. So, what we can do, we will do this data mining, that means whether a person is a cheat or a normal person based on the previous history of cheats and non-cheats, and this previous history is our data, that is our data, that is what we will mine. Say maybe the bank has so far granted say 1 lakh loans in this year. So, all these records of this 1 lakh loan that has been granted or not granted in this year is our data. How do we represent this data? We represent it like a table. What does the table say? Each column of the table is some fact or some characteristics of each of these loans, each of these loan applications. What are the characteristics? For example, one characteristics is where if I have given a loan, whether the person has refunded the loan, returned back the loan. Similarly, what is the marital status, single or married? Similarly, what is the tax, the income tax the person has paid, taxable income the person has paid. So, these three values somebody who has applied for a loan will write down in the application, and these values are my data for that particular application, for that particular person. So, you can see that each row in this table, is one loan application, and the last column you can see it is also a variable, an attribute, but it is what our interest is, to infer whether that person is cheat or a cheat yes or cheat no. So, that is a special attribute that we would like to infer, or the output of our mining algorithm. So, now let us come to some terminology. Each of the columns, in this case a loan application, is a object. It is a object, and each of these columns, which are measurements on that particular object, are the attributes or the properties of that object. So, examples may be the eye color of the person, maybe some temperature of some quantity. So, these attributes have other names also. They are also sometimes known as variables, they are also sometimes known as features, they are also sometimes known as inputs. Okay. So, these are the variables or attributes, and each of the rows are these attribute values for a particular object, and they are known as either records or samples or instances or cases or entities. Each of these names are popular depending on the application. One important thing to be noted is that this particular representation, if we examine a row, you can think of each row as a vector whose components are these individual attribute values. So, these vectors are also sometimes known as the object vector or the feature vector, a description, a representation of the object in terms of a vector. What is the dimension of the vector? The dimension of the vector is determined by the number of attributes you have. So, if you have 3 attributes, in this case it is a 3-dimensional vector, and since every vector can also be represented, for example, here every row except for the last column can be represented as a 3-dimensional point, a point in a 3-dimensional coordinate system. In general, if you have n attributes, every object can be thought of as a point in a n-dimensional coordinate system. So, thus our data is nothing but a collection of such vectors, where each vector is a n-dimensional feature vector or a attribute vector or a n-dimensional point. This is this is I think very intuitive and very common representation of the data, but what you should keep in your mind when we do further data mining is that you should understand that every input data, every data object can be viewed as an n-dimensional vector whose components are the attributes, or a n-dimensional point, equivalently an n-dimensional point. Okay. So, one of the advantage of this visualization is that you can actually plot your data on an n-dimensional coordinate system. visualize them as points. So, a collection all these loan applications over the past year, maybe 1 lakh can be thought of as 1 lakh points in a 3-dimensional coordinate system. Okay. And once you do that, it helps us to visualize what the nature of the data is. Okay. So, now, so the takeaway from this slide is that your data will be usually represented as a table, where each row is a n-dimensional vector representing one object, one instance of the data, when columns are the coordinates of this n-dimensional object, which represent the attribute values or certain properties of these objects. Now, the values that each of these attribute take can be of the following type. It can be something called a nominal attribute, nominal coming from the word name. That means, it is just a symbol. Okay. For example, the ID number of a bank account, it is just a number, it has no other meaning, it is just a number, a ID number. Eye color, say black or white or blue. Zip code, the pin code of a place. So, these are just numbers, these are nominal values, these are just some identifiers. Why these are just symbols? Because suppose a person has a bank account number, say 1001, and another person has a bank ID number, bank account number or ID number, say 1002. You cannot really say that the person with 1002 is greater than the person with 1001. You cannot compare these values. They are just, for example, my name is Pavitra Mitra and another person's name is say something else, say Ram Kumar. So, it does not tell us about anything more besides our identifier. It does not tell us that Pavitra Mitra dictionary order is before Ram Kumar, so he is greater than Ram Kumar. You cannot compare two names. Okay. So, these are just nominal values. The other type can be ordinal attributes, where you can actually compare the values, you can rank them. You can, ordinal comes from order. For example, you are rating a movie or a potato chips, for example, in a scale of 1 to 10, how good it is or how bad it is, or any product. So, naturally these values 1, 2, 3, 4, they can now be compared. 7 is better than 5, 3 is worse than 10. Whereas, ID number, a person's bank account number cannot be said that it is less than the other. Or for example, say height of a person, tall or medium or short, you know tall is greater than short. So, you can actually compare ordinal values. The next type is what is called interval valued attributes, where the value represents some intervals. For example, a date, calendar date, it tells you that whether another date, if you have say the date of loan application, the another date, loan application and loan granting, let us say, these two dates you can say that one is within the other, it falls in the range of the other. Okay. So, you can say that one belongs to this interval, one does not belong to this interval. Similarly, the temperature in Celsius or Fahrenheit, they are scales, they basically represent a range of value. The fourth type is what is known as a ratio attribute type. These are like free numbers, they can be anything. For example, a absolute scale in temperature, a length, a time, some count of something. They are neither interval, they are free values, you can do whatever you want to do with them. You can add them, you can multiply them, okay, you can compare them, all the properties of the previous attributes you can do to them. Now, let us look at some properties of these attribute values. So, whenever we have say two objects having different attribute values, in this data mining process we would like to perform some operation, some kind of basic computation on these values. What are the computations? You can, the simplest form is checking for distinctness, whether two values are same or are they different, equal to or not equal to. Just that is your universe, that is the only option or operation you can, only comparison you can make, either they are equal or they are not equal. For example, two names, only thing I can do operation between two names is that either it is the same name or it is the different name, no other. You cannot make greater than, less than, multiply two names, has no meaning. Only thing that has meaning is that whether two names are same or are they different. A slightly more complex operation is the order operation. You can check whether a value is greater than another value or less than another value. You can find their order, relative order. And then you have the addition or subtraction operations, where you can add two values, and finally multiplication and division operations. Now, in the different type of attribute values we discussed, it is only some of these operations that we can perform. Let me, for example, say you consider nominal values, names, account numbers. The only operation you can do on them is check whether they are distinct or not, no other. You cannot add them, you cannot check their order, nothing you can do. If it is a ordinal attribute, you can either check for distinctness, whether they are identical, or you can check for their order, whether one is greater. Say for example, a movie rating 7, either it is same as another movie rating or it is better than another movie rating. You can check for order and distinctness. For interval value attributes, where you have intervals, say date range or time range, you can do distinctness, you can do order, whether the one has applied for a loan before another person, whether at the same time or before that, and you can add them also. You can join two intervals and make larger intervals, you can add them also. Finally, for the ratio attributes, you can perform any of these four operations. You can multiply them also, you can divide one length by another length, whereas you cannot divide a date by another date. Okay. So, the reason I am explaining this is that in your real life application, your data table that you get might contain attributes which might be any of these types, Okay, they can be, for example, consider a bank loan. You have ordinal attributes, which is the bank account number. You have order attributes, which is maybe the bank balance of the person. You have interval attributes, how long the account is valid, and you have ratio attributes, maybe what is the rating, credit rating, or not the credit rating, maybe what is the income of that person. Okay. So, you can have mixture of these types, and each of the data mining algorithms that we will discuss in this course has to be redefined based on what kind of data, what kind of attribute the mining algorithm will apply to. You have to redefine. When I describe the algorithm, we will see how do we adopt them, but I want to make you aware that these are the different types that you will encounter. Okay. So, this is a slide which describes in more detail what are these attributes and what are the operations you can do on them. So, you have nominal, you have ordinal, examples of them, and what are the operations we can do. Note that any data mining algorithm which requires you to compute some operation, maybe the geometric mean of a set of values, is applicable to a data type only if that particular operation is applicable to the attribute type involved in the data. For example, if you are dealing with nominal attributes, you cannot apply a data mining algorithm which computes geometric mean, because geometric mean is defined only for ratio attributes. Okay. So, when you decide on which algorithm to use, you have to make sure that the operations involved in the algorithm is compatible with the attribute type. In your normal programming also you have done this. In your C programming you define integer and float and character, and there are some operations which are defined only on characters and not on integers and so on. So, your similarly in data mining, whatever operations you do has to be compatible with the data type. Okay. Among the ratio attributes, there is one more division, the length, time. Among them also there is one more division. It can be discrete or continuous. Discrete means it has a finite set of values. Example, zip code, number of words in an email, count of the words in an email. Often these type of values can be mapped to integers, integer variables. A special case of this integer or discrete attribute is where you have only two possible values, a binary attribute, yes or no. On the other hand, there might be continuous attributes which can take on any possible, infinite number of possible values. Height, potentially it can take on any value. But the fact is when you represent in a computer, you cannot represent arbitrary precision. So, you have to use some precision, some double or float or something which will restrict what is the precision. But theoretically continuous values can take on infinite number of possible values, infinite continuous attributes. Again, there are some algorithms which will work only for discrete values, and there are some algorithms which will work only for continuous values. Just like floating to integer conversion in programming language, you can convert a continuous attribute to a discrete attribute by defining intervals, a process known as discretization, which we will discuss in detail again. Also, this table format that I had mentioned before is what is called a record data. It takes the form of a matrix 2 by 2 structure. Many transaction data, even text document can be represented in this form. I would like to mention in this context that there are other forms of data beside the vector or a record form also. For example, there is a graph data where instead of vectors you can represent data objects as graphs. For example, the friendship structure in Facebook, you can say every Facebook user is a node of a graph, and if they are friends there are edges between them. Similarly, you can have molecular structures where every atom is a node and a bond between them is an edge between them. So, such molecular protein structures or protein molecules, they are better represented as a graph rather than a record. Again, the mining algorithms which work for record has to be modified if they work for graph. Similarly, we have a sequence or a ordered data, where in a vector every component have no relation among them, they are as it is, they are values. But sometimes a set of objects is defined only based on the previous and the next value. For example, when I am talking, I am giving a speech, you can make sense out of my speech not as individual sounds, but as a sequence of sound, this and this and this. Data mining, da and ta and my and ning, like this. Only this sequence makes sense. Only this sequence makes sense. If you put it in other permutations, the same sounds da and ta and mining does not make any sense. It has to, so, the third data type is a sequential or a ordered data type. So, this sequence need not be over time, this can be over space also. For example, I have a geographical information system, a map data, Google map, and I have information about localities, the some restaurant is here, some shopping mall is here, but they make sense only you put them side by side in a neighborhood, in a, as a map, in a two-dimensional structure, only then they make sense. These are called spatial data. Okay. So, here there is a road, here there is a lake by the road, here there is a park by the road. This configuration, this spatial structure among them is what is important. So, we also have lot of algorithms for each kind of this of these data sets. I will be covering mostly algorithms for record data, some algorithms for graph data and few algorithms for the temporal data or the sequential data. So, for the moment our data will take this plain and simple form of a table. Each row is a point or a vector or an object, each column is an attribute. Each column is an attribute. We call it a data matrix. Here is another example just to reinforce. You have, say you are measuring a industrial processing of some car part. So, you have the load of the weight of the car, along x direction, you have the weight of the car as loaded in the pressure in the y direction, the distance the car has to be traveled, the total load of the car, the thickness of the part and so on. So, this matrix is what we would call a data matrix. It has as many columns as the number of attributes, it has as many rows as the number of objects, number of instances. Usually, our notation of the number of attributes would be the dimension or capital D, and the number of rows would be the number of instances or sample size, usually represented by capital N. So, you have, let me write down, this is capital D, the dimension, and this is capital N, the number of points, a D by N. I have written M by N here. So, a D by N matrix. So, with this in mind, let us we'll just to quickly mention that this matrix, data matrix, is also a quite powerful representation. This is not a simple representation also. For example, I can represent text, for example, news article. How do you represent it as a data matrix? You do it in the following way. Every different news article, I call them as document 1, document 2, document 3. So, these are my instances or objects, and the attributes are, for example, the dictionary words that appear in this document. So, here I have a team, coach, play, ball, score, game, win, loss, timeout, season. So, these are the, for example, these are the only dictionary words, a sports news article. So, each of the dictionary, you have as many columns as number of words in a dictionary. These are the attributes, and each document is a vector containing whose dimension, whose number of components are same as the size of the dictionary. And the values of each of these vector components is how many times the dictionary word appears in this document. For example, the word team appears 3 times, the word coach does not appear, word play appears 5 times, and so on. So, you can see your news article as a bag of words, a collection of words, and which is equivalent as a vector of words which contain the count of the number of time each dictionary word appears in this document. And if you have m such documents, your m by n matrix is your text matrix. So, you can represent your text data also in this format. You can represent your transaction data also in this format. Suppose you have gone to a shopping mall and you have bought say bread and coke and milk, and another person has bought bread and butter, bread and beer, beer and coke and milk and diaper. So, each of these rows are different customers, the market basket or whatever the customer has bought, that list. Now, I can also represent as a vector, a binary vector. What I do, I see that I form a vector with as many columns or as many coordinates as the number of all distinct items that the store sells, all the items that the store sells, a large dimensional vector. And whether a person if a person has bought that item, I make a vector that component is 1, if that person has not bought, that component is 0. So, I have a binary vector representing a purchase list. So, that is also I can. So, now if I look at all purchases, it forms a matrix. So, I can also represent that. Graph data, for example, this is a Facebook graph where you have nodes and connections between them representing friendship, or you can have a web page. Each web page is a node, and if one page, if you click on one page, if it goes to the other page, hyperlink, there is a edge, directed edge. This is a graph data. This data cannot be represented as a vector, it has to be represented as a graph. It is difficult to represent it as a vector. Okay. So, we will look at that also. Similarly, you can have sequence data. For example, these are amino acid sequences that appear in a gene. This also cannot be represented as vector. Okay. But initially, as we start, we will focus on our vector or record type of data. So, with this, I think you now have an understanding of what are the different type of data. So, you have record data, you have graph data, you have sequence data. Record data consists of number of vectors, each representing an object containing a number of columns or attribute, whose values can be ordinal, nominal, interval or ratio. Depending on what type it is, I can perform different kind of operations on the data and accordingly design and mining algorithm. So, this puts in front of us a picture of what is the input, what are you going to deal with using our algorithm. In the next class, I will focus on the before you actually perform the mining algorithm, even if it is in any of this format, graph or vector or sequence, you can have problems. For example, various entries of this matrix are missing. For example, I have this data matrix, and suppose some entries are not noted down. A person has not disclosed his marital status, you have a missing data, or in the application the person has mistakenly put some value. Say taxable income, somebody has put a negative value or 0 value. So, these are noises or outliers, or they are null values or missing values, or maybe there are some attributes which are not important at all. For example, the name of a person is not important. You do not decide whether a person will be cheat or a non-cheat depending by his name. Name does not matter. So, you have non-important attributes. Similarly, there may be some data who has not at all applied for a loan. So, that is a non-relevant data. What data preprocessing will do is that it will focus on only the relevant data, it will relevant instances of the data from on which to do your mining. Note that it is important to do your mining only from the relevant data. If you take data which is not relevant, you will get spurious knowledge, you will get false knowledge. You have to do it from non-noisy data, you have to do it with proper set of attributes, and you have to sort of proxy for missing attributes values. So, in our next lecture on preprocessing the data, we will focus on each of these tasks which help us prepare a nice and clean data on which data mining will give us valid knowledge. Thank you.